Hi, I'm Mateo Rodriguez.
I'm Kale Casa,
I'm Ben Espy.
and we're going to talk about integration. First, we're going to discuss integration of American society. It started with the birth of little Jackie Robinson in 1919, and he entered the MLB in 1948 by joining the LA Dodgers. Later that same year, Dwight D. Eisenhower integrated our military units in World War II. And approximately 6 years later, Brown versus Board of Education was passed in 1954. That integrated public school systems so people like me could be talking to kids like you today. And that led to the Civil Rights Act being passed 10 years later with the leadership of MLK. The integration of sports, our military, education, and American society as a whole has led to the betterment of our country.
So, one application of integrals can be found in chemistry with the integrated rate law. So, the integrated rate law is introduced by looking at how the concentrations of reactants in a reaction affect the rate of the reaction. So here we have an equation A plus B equals C. The concentration of A doubles over time while the concentration of B is constant and the rate quadruples. Then we know that A, seeing as it has doubled, we see that A is a second order part of the reaction because you have it's doubling 2 to the x equals 4. We can solve x equals 2. Then we can solve for B the same way. Look at B doubles here while A remains constant. The rate doubles, so thus we know that B is first order in this reaction. So we can solve our rate law being rate equals K times A squared times B. Then we must solve for K, which we do so by using 2 equals K times 0.1 squared times 0.2, thus K equals 1,000. So our rate for this reaction is rate equals 1,000 times A squared times B. Alright, so the last and least important form of integration is the calculus integration. And to do this, I'm going to bring Sexy back and show you guys the integral of e to the xy. And to graph e to the xy, it's not a function, so we have to set it equal to a constant. So e to the xy equal to 2. So there's the function, and the graph of this in the first quadrant looks like this. And so if the integral is the area under the curve, this would be the integral of e to the xy equals to 2. Now take for example, if we do e to the xy is equal to 10, the graph of the function looks like that. So there's more area under the curve. Therefore, as the size of the curves increase, the integral of e to the xy